Hello, everyone. Happy Friday. Good morning, good afternoon, wherever you are. Thanks for joining this webinar with us today. My name, again, is Nico Kabar. I'm a solution architect at Tigera. Been with the company for 8-9 months now, and previously was at Docker, and before that at Cisco. So pretty much my tenure within tech had been at the kind of intersection of containers and Kubernetes and networking and the cloud. Feel free to kind of reach out. This is my email. If there's any questions or anything you want to reach out directly, feel free to do that. Today, we'll be talking about network policies and providing kind of an overview between Kubernetes network policies, why they're important, how you can use them, and also kind of provide you also an overview of Calico network policies and understanding the difference between the two and when to use which type of network policy. So the format of this is we're going to have 30-40 minutes, and happy to kind of answer any questions you may have. Just feel free to kind of put those in the chat window. I can't see it while presenting, but I'm happy to kind of answer them once we are done. So let's get started. Before we begin, I want to kind of introduce you to Project Calico. So if you're not too familiar with Project Calico, it's an open source and community kind of driven project that started pretty much around the same time that Kubernetes did, and it's kind of aimed at providing the CNI. Started as a CNI for pod networking, kind of moved beyond that to provide network security for pods and even for virtual machines and host-based workloads beyond that. Kind of that project grew over the past 6 years or so. Now, why it's Project Calico has been pretty ubiquitous around it's used. A lot of users use it today because it's kind of simple, secure, and scalable network option for Kubernetes. It provides blazing speed, native Linux data plane performance. It provides layer 3 networks. You can have an encapsulation, non-encapsulation mode, but it started as providing a simple layer 3 network across your Kubernetes cluster, utilizing native Linux data plane functionalities. It is massively scalable, built on the routing protocol of the internet, that is BGP, and really the scale of it is kind of what Kubernetes scales to. So it is highly scalable networking designed for your Kubernetes workloads. We also have been adopted by all the major cloud providers, AWS, Google, Azure, IBM, and all four use Calico in some form in the managed Kubernetes cluster. It's also been embedded by Docker Enterprise as well as Rancher, and integrated with Red Hat OpenShift as a first-class operator-based option for the CNI. We have, beyond the open source, which is widely used and widely adopted worldwide, we know more than 150,000 clusters out there, Kubernetes clusters that are using Calico today, and it's been trusted by many companies and users and community members over the past couple of years. Now, Tigera is the company behind Calico, and we maintain Project Calico as well as provide many more solutions that build on top of the power of open source Calico to address a wide variety of enterprise and telco use cases and functionalities, and drive some of their compliance and security related use cases. So we maintain the project with the community, as well as built something on top of it that's called Calico Enterprise, that is also widely used and adopted by some of the largest and trusted by some of the largest enterprises and out there. You can see some of the names out there. They're all Calico Enterprise customers today, and they're trusting their workloads, business critical applications with with Calico. In terms of where you can actually deploy and use Calico, pretty much anywhere you can have Kubernetes, you can run Calico, and actually beyond that. So as I said, all four major cloud providers, their managed Kubernetes use Calico, at least for network policy. So if you go and run EKS, GKE, AKS, IKS, you have the option to enable network policies, and the network policies are implemented and enforced by Calico. And I talked about kind of how Calico is being adopted by other Kubernetes distributions like OpenShift, Docker Enterprise, and VMware Tanzu and Rancher and more. So you can basically run Calico and use Calico and Calico Enterprise anywhere you can run Kubernetes. But not only that, as I mentioned earlier, one of the things that we've seen over the past couple of years is that the model that Calico and network policies provide had made it even more interesting to use that model with outside of Kubernetes. So we have a lot of use cases where our customers are using Calico for what is called host endpoint protection. So native Linux workload, whether they're running on-prem or in the cloud. So using the same YAML-based definition of policies can be applied to both Linux workloads outside of containers as well as container-based workloads on Kubernetes. So why use network policies? So as you might be aware that Kubernetes by design is designed to kind of have a flat network. That means that there are two kind of dimensions around networking. One is network connectivity, right? Making sure that pods can communicate when they come up, and all that takes to make sure that they're reachable at layer 3, regardless of the pods can trying to talk to each other or talking to services within the cluster or talking to external services outside the cluster, and kind of all the ingress traffic coming to them. All that is kind of in the bucket of network connectivity. But that is something that is that is separate and different than securing those workloads. So there's two buckets, two dimensions around networking when it comes to Kubernetes. One is around network connectivity. One is around network security. And CNIs usually in Calico specifically comes at the intersection of those two. So you can actually use Calico for either or, right? You can use it only to provide the network connectivity. You can use it only to provide network security, or both. So, so why do you need network policies and network security? As I said, so by default, when you bring up any Kubernetes cluster, every pod can talk to any pod within any namespace. So it's pretty flat, pretty open. There's because of the dynamic scheduling of pods come up and go down. That means that the IP addressing are ephemeral, they're short-lived. The pod location is non-deterministic. You don't usually determine where the pod is going to be running, what IP is going to be getting, and you shouldn't be really with the new model of Kubernetes. And finally, because of the nature of that, in a lot of cases, not always, the IPs of the pods are non-routable. That means that outside of the cluster, the IPs don't mean anything. They're locally significant to the cluster. So because of those reasons, you actually do need a network policy that would make sure that you're securing their workloads based on your requirements, your application requirement, especially if you're going to a microservice-based architecture where you need to make sure that different components are allowed to speak with other different components, and only in certain ways and only based on what you expect the application to and how do you expect the application to behave. So shifting kind of towards what was needed to kind of take a new approach now that we have, Kubernetes is defining a new cloud-native approach to deploying the applications. There needs to be a better and new approach to how you create policies. You can't just take existing firewalling and ACL-based approaches because of the limitations or restrictions that I kind of mentioned around, the IP addressing not being deterministic, being ephemeral and non-routable. So this new approach needs to be label-based because everything else in Kubernetes is label-based. So using labels and selectors to group applications and apply policies on certain workloads. It needs to be declarative. That means that you declare, using any tooling that you have, you declare the end state of how you want to secure the application, and then Kubernetes and Calico take care of the rest. And of course, it needs to be dynamic. You can't afford waiting for weeks to open up a port, and especially with the speed at which applications are being deployed and pods come up and go down. The implementation enforcement needs to be on the magnitude of milliseconds or microseconds in order for it to be effective and not not impact the deployment or the the application speed, the speed to deliver an application. So if we take a look, before I kind of move forward into like the types of network security, types of network policies, this is a good way to kind of compare, if you're coming from a traditional network security approach, on-prem or in the cloud, you're kind of, segment-based or VLAN-based or zone-based firewalling, and comparing it to, Calico's cloud-native approach, you're going to see some key differences as are highlighted here. I want to focus on three and kind of, bring your attention to them. One is around where the policy or where the network security needs to be enforced or is enforced, and that is traditionally they're enforced outside the VM or outside the rack or outside even the set of VMs at the firewall level. It could be within the network or could be before the network layer, but it's not close to the application. While with Calico, we're enforcing the policy, the network policies at the interface of the pod. So within the VM or the instance, within the Kubernetes workload, we're enforcing all of these network policies as close as possible to the pod. That means that there will be no unintended traffic even going and hogging your network if it's not if it's meant to be dropped. So we implement it in both ingress and egress direction as close as possible to the pod. The second one I want to talk about is how the dynamic nature of both creating the policies as well as enforcing the policies. As I mentioned, because of the label and selective based approach, it's pretty dynamic of how selective you can be on how you want Calico to secure those pods or applications. You basically label the pods and create a policy that applies and selects those labels, a combination of those labels, and Calico takes care of the rest in terms of it dynamically calculates which pods and which nodes need to have that policy, and it kind of enforces it then. And finally, as I mentioned, kind of the speed at which the policies are enforced. It could be taking in the manual process, could be taking even minutes, and even if we're not talking about a kind of change management required to implement a new opening up a port, but even the enforcement in a hub and spoke or kind of controller based or centrally managed policy approach could even take minutes. While in the Calico distributed approach, it takes milliseconds. Please remember that Calico runs on every node in the cluster, and there's no management plane in a sense that it doesn't have a centralized management plane. Every node in the cluster is actually talking directly with Kubernetes API server and etcd in the backend, and because of that dynamic and distributed nature, it is highly scalable. There's no one single failure point for calculating and grabbing those policies and enforcing them. So let's talk about Kubernetes network policies. So if want to differentiate, want to talk about Kubernetes network policies, and then we're going to talk about Calico network policies. And if you're not aware of the differences, this session is gonna help you understand that. So the intention of using Kubernetes network policies is to let administrators or operators or even application developers define their network rules using same deployment artifacts. So it's similar to how you create a YAML file to deploy the application, or use Helm, or whatever method you're deploying the application, or your CI system deploying the application. You can use the same thing to actually create an artifact that defines the security posture and how you intend to secure the application. It is supported natively with the network policy Kubernetes API that's in-stream. within Kubernetes itself. So pretty much every Kubernetes distribution that you use, I think it was introduced in like 1.5 or 1.6, so it's been there for a while. However, Kubernetes itself does not enforce those policies. So it understands the policies using Network Policy API, but it relies on the CNI itself, Calico, in many cases, and there's other CNIs out there, to actually enforce the policies. The policies are namespace scoped similar to a lot of things in Kubernetes. So if you have two namespaces, you have to create separate policies to be defined for every namespace. And it is applied to the pods using labels and selectors, as I mentioned. Now, you can apply the policies on, the selection of the traffic selection can be based on the namespace. So where, from its namespace, a specific namespace to a specific namespace, from the pods using labels, or from IP siders. So it can be even the IP, enable or allow traffic to this specific IP or IP set, or from this IP. And of course, those, it can be, you can use kubectl to apply and create those policies. In addition, you can actually use the policies for both to allow and deny TCP and UDP, and you can have ports assigned. Actually, and I think with network policies, you can't use port ranges. I think I need to take that one out. But you can use allow deny traffic for both TCP and UDP traffic as well. And of course, we talked about this. It can be applied in both ingress and egress direction. Looking at the pod, ingress is all the traffic coming into the cluster or coming into the pod, and egress is all the traffic leaving the pod. Now, I want to point something out that by default, if no policy is applied to a pod, all traffic is allowed to and from the pod. This is what we defined, what we talked about earlier. You bring up a new Kubernetes cluster, and everything can talk to everything. So there's nothing really preventing any pod to talk to any other pod. Now, the default behavior that I want to make sure that I'm highlighting here is that as soon as you apply any policy, right? Any policy that is applied to a pod, for that pod specifically, only that out traffic in that policy or any aggregate policy is going to be permitted, and then there's going to be basically a default deny after that. So if you don't touch the pod, you don't, out of the box, everything can talk to everything. The moment that you apply a policy on that specific pod, it assumes a default deny. So unless you allow certain rules within the policy, it's going to assume it's a default deny. So be aware of that. So let's take an example. I don't know if you've already seen, network policy, great, but I'm going to go through some examples for both Kubernetes network policies as well as Calico network policies, and highlighting some of the use cases. Some of them are real, user customer use cases that we were highlighting here for you. But as a simple example here, you can see this is a simple YAML file defining this policy, and in my application running in the my namespace namespace, three different services with front-end service, a helper, and a DB. And my intention from creating the policy here is to make sure that for the DB pods, for the DB service, they only accept traffic and allowed to accept traffic in the ingress direction coming from the front-end service, specifically on TCP port 6379. So you can see here that I'm defining this policy in the my namespace namespace. I am applying it using the pod selector on the DB. So this is where the policy is applied. It's applied in the ingress direction, and I'm only permitting traffic from pod selectors, right? With label, all the pods labeled front end, and only trying to connect on port 6379. So the moment I deploy this policy, it's going to be only applied on the DB pods, and it's only going to allow traffic coming from the front end of that port. That by definition, any other traffic, whether from the cluster, outside the cluster, is going to be denied. So this is a good example of kind of being specific around the policy for a specific use case and understanding the default deny behavior. Another example here is kind of, in this case, I'm not going to use pod labels to define the, how I want to allow the traffic, but I want to use CIDRs and CIDR ranges. So in this case, I want to be able to have this pod or service with color equals red to be able to connect to an external set of services on this IP CIDR or subnet 172.18/24. And because I applied it in the egress direction, you can see here only talking to this specific CIDR. If I try to connect to 10.10.10, it's not going to allow me to do that. So the highlight of this is you can use CIDR specific IPs or even full ranges when you define how you want to accept or deny traffic. Another example is a deny or default deny. So we said we have a default allow, that's kind of the default behavior, but a lot of users and a lot of customers I work with, they start off and they automate when they create a namespace or a project. They start with a default deny, and in this case, you can see here that it is matching all the pods within that specific namespace, and in both an ingress and egress direction. But because there are no rules here defined, that means that it's going to actually block all the traffic. So this is a good default deny that you can start with, and then as you can add more rules beyond that, but starting with the default deny is a common best practice that we're seeing. So now that we kind of talked about Kubernetes Network Policies, let's shift focus to Calico Network Policies. So Calico Network Policies extends Kubernetes Network Policies. It is going to provide pretty much everything that Kubernetes Network Policies provide, but extends the capabilities beyond with a set of very powerful capabilities. So I'm going to go through a couple of them, and I'm going to show you some of those examples as well. So the first thing is that when you want to use Calico Network Policies, you're required to use Calico as a CNI because that's, it needs to have that there. You can use Calico. You need to use Calico for policy enforcement. So for the managed Kubernetes services like EKS, AKS, and GKE, this actual CNI that is used for connectivity is a cloud CNI. So for EKS, it's like VPC CNI. But when you add on Calico for policy, Calico will be deployed, but it's only going to be responsible for policy enforcement. So in that case, you can, by default, if you use any of those services and you enable policy enforcement, by default, you can use Calico Network Policies. We have a tool with Calico called Calico Cuddle that is a very easy to use tool to interact with Kubernetes and kind of look at it from anything related to policies and network security. So it's a very handy tool, and that you can use also to create and apply and look at the policies. I think it's more easily than even kubectl in that sense. Calico Network Policies support policy ordering precedents. That's something that Kubernetes Network Policies do not do. So if you are coming from the Apple world and you want to have a precedence for how you order the enforcement of policy rules, you can do that with Calico. We also support not only layer 3 and 4, so at the IP and at the TCP UDP levels, but also extend that capability all the way to layer 7 with Istio and Envoy. We have a capability called application layer protection that basically allows you, kind of the gist of it is defining a single policy, and in that policy you have rules that allow or deny traffic at the layer 3, layer 4, but also layer 7. So you can have it within the same rule talk about accepting traffic on TCP and only HTTP gets. Now, by having them in one policy, in one YAML definition, it's easier to manage. But how they're implemented and how they're enforced is separate. So Calico takes care of layer 3, layer 4 enforcement, and rely on Envoy for layer 7 enforcement. So But from a user experience perspective, you're defining a single policy and you're defining it in one place. So that's a key capability that's available for you out there to look into. Next one is you can protect VMs and host interfaces, not just pod. I think I talked about this, but it's really, you'll be surprised of how many customers that we have are using it in that way. And the reason why is that because everything is moving, or a lot of enterprises are moving to cloud native architecture and processes, and the ease of the ease of creating this uniform language, right? And uniform security layer to protect both Kubernetes workloads as well as non-Kubernetes workloads, and create some commonality around how you define an application. I had a customer that defined a tenant with certain labels, and some workloads are sitting in Kubernetes, and some workloads are sitting on EC2 instances. And by defining a single label that define both workloads, they are able to actually create policies that are going to be implemented on both sides of the house and protecting that application using the same YAML and same deployment configuration. So it's a great use case for using Calico. We also support namespace scope and global scope. So global scope means that you're going to actually create a policy that can be applied selectively to certain namespaces or across all namespaces and all pods. And that's the value of that. You can actually create as I said, the policy that if you have, more global set of rules that you want to allow or deny, you can actually define it once, and it can be applied to all the namespaces within your cluster. Next up, you can, with Kubernetes Network Policies, you basically have only whatever you define is allowed because there's a default deny in the policy. But with Calico Network Policy, you actually have the flexibility of specifying the action. You want to allow the traffic, you want to deny the traffic, you want to log the traffic, you want to pass, and there's a certain combination of the two. So it's a bit more granular what you can do when it comes to enforcing the traffic. Last but not least, how you define the traffic or how you select where the policy needs to be enforced is really important. So you can, you can select it on the pods using the pod labels. With a global policy, you have a mechanism to select the namespace. So, traffic coming from this namespace or applied to this namespace. Now, an additional thing that we've done with Calico, and it's very critical to understand the value of it, is using service accounts. And the key thing that using service accounts and why it's recommended is because using pod labels are not RBAC. That means that if a user or an application owner is allowed to create a pod, that means that they're allowed to adjust its labels. So there could be scenarios out there that an activity, a malicious event that could take over and update certain labels for a pod that can help escape certain network policies, Kubernetes network policies. While if you apply them at the service account level, service accounts are typically not created, or from an RBAC perspective, their labels are RBAC, they're RBAC, and therefore, and usually they're created and given to the consumers of and users of Kubernetes, and they're usually not created by the developers or the application owners or the SREs themselves. So therefore, you have a much more granular level of securing and creating policies that utilize service accounts instead of pod labels. Now, all of the stuff that I talked about here is all open source in Calico Network Policies. There's nothing really about them that is in closed source or in not available for you. So if you use Calico for enforcement, policy enforcement, you can use those capabilities. Now, we use Calico Network Policies as a foundation for some of the advanced capabilities in our enterprise platform. I'm going to talk a bit about this, but this is not the core of our discussion here. But just know that there's a lot more to it than just what I mentioned here. We have things like DNS-based policies, where you can use the fully qualified domain name to specify where the pods can talk to. Policy tiering, so you can have actually classes of policies and better management. There's a UI around them. Policy previewing, so that way you can actually understand the impact of the policy based on real-time analysis of the traffic so that you understand the impact of the policy before you apply it, and policy staging, and you can collect a lot of metrics around what's going to happen if I apply the policy before you do so. All of these are capabilities within Calico Enterprise. And I'll leave some info towards the end if you're interested in checking them out. So let's take a couple of examples here for Calico Network Policies. So as you can see here, the first distinction is that the API version is Project Calico and not the networking.kubernetes.io. So you need to have, if you installed Calico or you're using Calico in a managed Kubernetes cluster, automatically you're able to use this API version because it's going to be part of the added API groups. And the kind for this example is a global network policy. In this case, you're basically applying a global network policy that applies only on all the namespaces with the label. So you can selectively apply a global policy and use labels to select which namespace this will be applied on. And also you can select use namespace selector to select which traffic or which namespace you're allowing the traffic to or from. So this is another example where you're starting more of a namespace level policies versus pod level or application level policies. And as you can see here on the right hand side, you can actually use kubectl to interact with the policies and for both Kubernetes as well as Calico Network Policies. The second example is a bit more advanced here. In this case, what I'm trying to do, or what this user was trying to do, is to make sure that we're using the service account selector to deny traffic to the helper pods coming from the SRE account, service account, and allow ICMP traffic coming from the namespace with label color equals green. So there's a lot of things going on here. So let's kind of dig in. So you can see here that this is a Calico network policy because of the API version. This is a network policy, not a global network policy. So it just applies to the my namespace namespace. One thing you'll see here that we provided an order, so we can actually start, including ordering. So the lower the order is, the first it gets enforced, and so on. We're applying it to the helper pods. This is pretty straightforward, and we're applying the policy in the ingress direction. So all the ingress traffic will be inspected, and this policy will be enforced in that direction. You can see here there's an action verb to deny the traffic. So it's not, you can do allow, deny, log, and pass. So we're denying traffic, TCP traffic coming from all the pods, any traffic coming from a service account that is the SRE account. So it doesn't matter, where it's coming from, as long as it's coming from this service account, it's going to be denied. And the second action that we want is to log all the ICMP traffic coming from the namespace selectors, so coming from any pod from this green labeled namespace. So here we're logging means that we're just providing logs. We're not taking any action for it. So it's going to be allowed, but we're going to log all those connections. And you can see those. This is the logs that the CNI logs that is available for you locally, and you can just use it with use any logging solution to get that set of logs to wherever you use your logging centralized logging solution. So the next one is around the Calico Enterprise policies. Just a recap of that, and just kind of showing you the value in the case you're interested. So the right-hand side, you can see actually this is a snapshot from the UI of the platform. Everything is backed by the API, and you can use it in YAML form or in the UI. Each of those columns are a tier, what we call a tier. So you can actually provide a high precedent tier where the policies are applied left to right, top to bottom. So the security tier can provide certain policies that are applied and enforced before, like, the application developers even get to apply their own sets of policies. So if there's a security measure or security control that needs to happen globally, and those policies can be enforced, and make sure that you're globally enforcing certain policies, regardless of the application developer or the application owner's preference around security policies. You can see here a couple of things, and that I wanted to highlight. One is around as I said, the UI, the tiers. You can see here in the name of the policy, you have the tier name. We have the second thing that I wanted to showcase is this staging label. So some policies you can have, you can stage them, that they're not enforced. You can make some adjustment. You can preview them and then move them to an enforced stage, or move them to enforced mode. And you can do RBAC around that. Who gets to adjust a staged policy versus who gets to adjust or tweak a policy that is not staged, that is actually being enforced. Finally, one of the things that you'll probably see here on this rule over here is that we're using what is called DNS-based rules. So we provide a fully qualified domain name or subdomain or wildcard in the egress direction to allow or deny the traffic, and Calico in part uses the DNS response to program the right set of policies and be enforced in the egress direction. And the value of this is that if you are trying, these days you don't want to be, for traffic leaving the cluster going to other external services or to other managed cloud services like RDS or specific APIs or Azure AD or whatever it is. You want to specify a fully qualified domain name for your instance of a database instead of an IP address or set of IP addresses. Because in that case, you can't actually use labels because it's an external resource. So it's not really within your Kubernetes cluster. So therefore, you need to either use an IP address or a DNS or a domain name. So we allow you to use a domain name to do that, and that helped a lot of my customers just avoid manually, dealing with setting that type of policy. So a couple takeaways, so we can leave some time for questions, and I'm happy to kind of dig into the UI and the enterprise features as well. But a couple takeaways on this Friday's session is, Kubernetes Network Policies enable application to declare segmentation controls, security controls to allow and restrict access to the workloads. Calico Network Policy is more of a sophisticated, advanced superset providing superset capabilities beyond what Kubernetes Network Policies provide. And then Calico provides a kind of scalable implementation of securing your Kubernetes and non-Kubernetes workloads in proven and very large-scale deployments today. And we talked also about some of the advanced capabilities in Calico Enterprise when it comes to network policies and the management of network policies. And this is one of the greatest kind of value-added features that we provide to our customers to help them manage and secure their workloads. From a central place with certain, especially if they have compliance and auditing requirements. So it's a central management plane for network policies and beyond. So a couple of resources before we head to questions. Project Calico.org is a great starting point if you want to learn more around all the details on what you are capable of, everything that's happening for both Calico and Kubernetes Network Policies. We have really good examples there, so feel free to head to our site there to learn more. I also recommend, and maybe I'll put it in the chat, Ahmed is an engineer. I think he's at GKE, but he has this repo which has really long list of real use cases with demonstrations on Network Policies. I don't think he uses Calico Network Policies, but even just using Kubernetes Network Policies to illustrate what you can and can't do, which is like, it's an extensive set of capabilities that you have. So I definitely recommend it, and I'll post it in chat in a minute. Another great resource. So in terms of upcoming events, so as you may know, with COVID and what's going on, we're actually shifting all of our enablement and our kind of outreach to our community and our customers to be more virtual. So we have 2 to 3 sessions every week coming from, a product, from customer success, and, talking about deployments, best practices, from my team, which are the solution architecture team, talking about various, technologies covering both open source and enterprise, and beyond, and even a lot with our partners coming up. We have an AWS event coming up as well. But you can see here is a long list of upcoming events, and you can always check events.io/events to check what's coming. And even this session and a lot of other sessions all are recorded and posted for you. So it's a great resource for you to have and get, continue this kind of learning path. And feel free to kind of reach out to us if you have any requests around sessions, or if you have any requests around your use cases that you'd like us to be engaged with. Finally, Calico Enterprise is I didn't dedicate a lot of time on it, but it's really great solution for you if you want to, especially if you're going, if you're part of an enterprise or team and you're scaling the number of applications and you want a supported enterprise solution for to help you with moving to Kubernetes and securing your workloads. We have a wide variety of capabilities and use cases. And if you don't have the resources to try it and you haven't been able to, we actually have a platform called the Enterprise Trial. So you can go to this site and you can get an instance based on different platforms, either Rancher, EKS, AKS, GKE, OpenShift, and you can get an instance of Calico Enterprise. And we walk you through a set of examples to help you understand how you can secure applications and some of the best practices around doing that. So feel free to kind of do that. It's free for you. So definitely highly recommend you do that. So I know I've been talking a lot, and I appreciate your patience. Now that I wanted this to be more interactive, but those kind of events I need to kind of deliver the content. But this is my time to go and see the question and answer part. So I'm gonna stop sharing so I can actually see that chat window. So there is a Q&A field here, and there's a chat window. So I'll start with the Q&A. Any details that can be shared on scale numbers in terms of numbers of pods per node and numbers of nodes in Kubernetes cluster? It's a great question. So scale is, I've dealt with a lot of customers who ask about scale. It's really subjective in the sense that there's a lot of factors that can determine how determine your scale. We've done scale testing, but we also if there's no public information around scale. But what I can tell you is that from my experience with customers, we've seen really the limiting factors of the number of pods on a node is Kubernetes and what you set as a max there. Because we use native Linux capabilities and we optimize how we enforce the policies, we haven't gotten, the only thresholds I've seen is 75,000 rules in a policy, which is massive. I've seen customers who deployed 60,000 pods across the cluster with more than 6,000, 7,000 services, and things were just fine. So long story short, we don't have any public reference. But if you have a scenario and you have a specific use case, please feel free to I'll put my email in the chat here. Feel free to contact me, and then we can help you with that specific scenario. So I'm going to put that. Oop. So my email is the following. And then I'll put also the link to that other resource here before I continue answering the question, because otherwise I'll forget. One second with me. Okay. Here's a resource. Okay. Okay, so done. Okay, so how Calico is ADF, so is that advertised or advantageous over other network plugins supported by Kubernetes? Great question. So that requires its own session, but I think if you go to docs or projectcalico.org, you can see some of the specific areas in which we believe we're more advantageous. I would summarize them in 3 key points. One is the simplicity of the architecture itself. I think if you ask any, even network engineer, they'll tell you it's actually a drop simple architecture with layer 3. The complexity happens with the interaction with Kubernetes and the policies and so forth. But in terms of network plumbing, it's that simple, and that's why it tends to be scalable. The set of options and capabilities that we have, most of them are driven by the community and the customers, is another key advantage. Although I said it's kind of, Calico is known for providing layer 3 networks, but we have an option for using VXLAN or IPNFP for encapsulation. So you can have an option to do routed, a layer 3 network with encapsulation. You can do a layer 3 network without encapsulation. We have a lot of customers who are even peering with their underlay, integrating Kubernetes with their underlay, advertising their pods, networks, and routes and service routes directly into their network. So there's a lot of capabilities around that as well. And then I told you it's pretty much ubiquitous in terms of its adoption. It can be deployed anywhere, so that's a huge advantage for us there. Hopefully that answers your question. Next question is, the day is listed. Oh yeah, so yeah, it's my bad around. My bad around the typo. It's the July 31st. I just want more days in July. I don't want it to feel August and the summer is done already. So I apologize for that. Next question: what is the best practice for defining namespace boundaries? Imagine you have one business vertical for Kubernetes clusters, Kubernetes Escado. Would trust boundaries be a good starting point? Is there a better mapping for security to label instead of namespaces? It's a good question. I think, I've seen before where namespaces were used for at the team, or like taking a team approach or organizational structure approach due to like how, bidding is done, or how the engagement, or how the engagement with the platform team is done. I've seen it done at a project level. So across a specific team, different projects, each is mapped within a specific namespace. So more of a functional approach to namespace creation. And sometimes even neither, actually a cluster pair entity. So therefore, it's from a platform team, they're given a full cluster for that use case and multiple clusters for different teams. So I guess it depends on what is needed. But regardless of which approach you take, what I wanted to kind of highlight, is that the capabilities within Calico or network policies can really give you that level of security to an extent that you can actually define. Even if it's a multi-tenant, multi-org, multi-team, define a set of policies that would truly protect you from any kind of, any namespace kind of bleeding into or impacting another namespace, at least from a network and network security perspective. Hopefully that answers your question. Does Calico support Kubernetes network, not CNI? I do not believe so. I think this is, I'm actually not 100% sure that answer because I think on is that referencing Azure specifically, if I'm not mistaken? Please kind of chime in the chat, and then I can help answer that question. But maybe we can I can take it also offline. I don't know the answer to that one for sure. How is the VM host interface level network policy is complied with pod network policy? Are there any specific recommendation when enabled both? Absolutely. So they're both. They can work independently. So you can actually deploy Calico purely on Linux workloads or purely on Kubernetes. The only thing that's required is a shared data store. So there we still, in either case, we still require something like etcd, or we interact either directly through Kubernetes API or directly to etcd. When they're combined, actually, you can harness the power of combining them because you can actually define labels that can be applied to both, and there's consistency around how you define policies across all of them or both of them. So in terms of recommendation, I think we define some recommendation in our documentation. It depends on what type of recommendation you're looking for. Akil, if that doesn't answer your question, feel free to kind of add more in the chat, and I'm happy to address them. I'm trying to go through as many questions as I can. When conflicting policies were created by mistake for same pod selectors, does Calico detect and report, or does not even allow to create such policy? It's a great question. I believe if the conflicting part is going to be denied, it's going to deny the traffic. So so if there's a policy that's denying the traffic and the policy that's allowing it's going to be denied. So it's going to take the more safe or secure way to do that. I don't know the answer to the kind of second part. I mean, Calico itself does not, at least not to my knowledge, kind of report on conflicts because it assumes that depends on how or where you apply the policy. There is an order for the policy enforcement, especially on the Calico Network Policy side. So it depends on where it is there. So it's going to look at that, and based on the order, it's going to decide on the traffic. Because even if it goes through the order, if it's going to allow, it's going to go through the next one and next one, and if that passes, then it's going to allow the traffic. So there's a denier conflict at some point. From my understanding, I'm like pretty certain, but still there's room for that. I'm not 100% certain, but if there's a deny, that's going to be denied. It's a good question. On to the, let's see how much do we have? A couple more minutes. Let me see if I can answer maybe one or two more. 1 second, please. So next question is, are you seeing people running IPv6 in Kubernetes? I personally have not worked with any customer who has, but I know some of my colleagues, especially in telco, they are using it, and they have IPv6 networks on Kubernetes, especially that Calico supports both from a networking and policy supports v6. The telco world had been using them. Does policies applied on the Linux IP stack introduce latency for voice-based applications? It's a good question. It's basically, I can share some links to the performance done on IP tables performance, and processing of traffic. As I mentioned before, Calico is pretty active and pretty fast in terms of programming IP tables. So if there's going to be a delay in terms of the actual traffic, it's going to be done by IP tables itself, and IP tables is pretty, it's a native Linux capability, so it's really pretty performance. But that doesn't mean that it's going to be. It's not at line speed, right? There could be some delay there, but I don't know that I don't know exactly for the voice-based application there's any significant delay to introduce jitter or anything due to that. I don't know the answer to that one. Kubernetes on top of OpenStack using Calico and Neutron, are we able to use a single plugin, since the idea is to use the Calico global and all have the feature Calico provided for both OpenStack VMs and pods? It's a good question. I'm not too familiar with how Calico and neutron can coexist, feel free to email me that question and I'll look into it, or Slack me in the Calico users or Calico communities Slack channel, and I'll be happy to research it for you. How are you differentiating Calico with Rancher in terms of superset of network and network in terms of superset networking and security aspects? There's zero competition or zero competition between us and Rancher. We're actually close partners. Rancher provides Calico out of the box as an option when you deploy any Rancher RPE cluster, and you can use Calico and Calico Enterprise on top of that. Actually, we're seeing a lot of opportunities that I'm dealing with right now where Rancher is great from a platform, from a multi-cluster management, but still in terms of network visibility, network policy enforcement, the capabilities that I talked about, that is something that they rely on Calico and Calico Enterprise to help with. Yeah, I mean, we work together. There's really not much, not necessarily competition, but as you said, differentiation is we're really good at network and network security for Kubernetes workloads, and they're really good at platform and platform management. So the two words are actually pretty good together. Hopefully that answers your question. I missed one question. How is the policy enforcement data plane? Any performance numbers on layer 3, layer 4? Policy enforcement using IP tables or for IP6? Yep, absolutely. So actually, it's better for me to share the link to the comparison we've done for IP tables versus IPVS and eBPF. So I'll do that for that question. It's basically asking around the performance, performance and scale for those different modes. So let me. I'm going to share that in the chat. So remind me again to share it because I want to answer maybe one more question before we drop. There's a couple more. Sorry, I'm not going to be able to answer one more, and then we'll feel free to email me if there's anything else. Happy to help. You mentioned that applying policies for service accounts are safer since the person who is deploying the app pods or replica assessor deploys can't have access to create them. Could you please elaborate a bit further on this idea? Absolutely. So typically, service accounts are not created by the service account or by the users themselves, right? Unless you give them that capability, and that's not a good best practice. Because of that, and similar to also namespace. So namespaces as well as service accounts both are typically pre-created for groups, but pods are created by the application owners, right? So because of that approach, you have you can RBAC namespaces in their labels, and you can RBAC service accounts in their labels, and you don't usually get permissions to change or alter the labels on those two types of resources. Because of that, using service accounts in Calico Network Policies can prevent intentionally or unintentionally users to escape network policies. Hopefully that answers your question, Jorge. And hopefully this session was beneficial to you guys. And thanks for joining us. If you have any questions, again, feel free to reach out, and hopefully we'll see you again in a future session. I'll hang around to provide that link for the IPVS and eBPF comparison. But other than that, have a good Friday.